So I've got a Sinclair C5 to do. It's not really a Sinclair C5. It's a chassis and a body shell. Effectively, I'm building an e-bike from there. Given what I've got, I can kind of go back to first principles and just build up from that. One of the most important things I want to do is to make it better than the original Sinclair C5. The C5 was a bit of a joke, really, for various reasons. It kind of didn't have the miles it was supposed to. It didn't have speed. It kind of was built with the technology available for its time. And it was marketed poorly, really poorly, looking at the full history of it. So what I want to do with mine is actually trying to put as good a job as I can into it. So modern motor, modern batteries, just see what I can do. Now there's kind of a few things with the law. Which is important to look at. So I think that's the first part. I've kind of looked at loads of e-bike forums, just trying to understand what's required with building an e-bike. But ultimately, in the UK, I know, if I get pulled over, the chances are, if it's in breach of any law, the police will kind of impound it, take it away, confiscate it. I just don't need that. But I do want to kind of push the design as much as possible. So I'm kind of thinking, would it be possible to have a kind of setup which allows me to drive on the road, comply perfectly with UK law, but then on off roads, off the public highways, I'm going to have some way of kind of just letting the rip. So looking at a bike now then, the bike's quite simple. It's just, an electric bike, you need a motor. And the somehow the motor drives a wheel. I mean, that could be a chain drive, whatever, but you've got a gear ratio here, which is dependent on the diameter of the wheel and all kinds of complicated things associated with that. Essentially, with a DC motor, whatever it is, you need a motor driver. And all that motor driver does is take power from the batteries, and delivers it to the motor. Now, typically on e-bikes, batteries, certainly with the original Sinclair, it's 12, 24, 36, 48. You go above that, you get into forklift territory, which is quite which is ridiculous. So the higher the voltage, the more efficient the entire system is for various reasons. Coupled with, obviously the batteries don't connect, so you have some kind of controller or whatever, that motor controller, so that actually takes the power from the batteries. That blinking out. That takes some form of input from the kind of throttle. Tells that the battery, tells the motor what to do. Tells the motor driver what to do. That drives the motor, which drives the wheels through the gears. Motor drivers, what they usually set up with pulse width modulation, which is a kind of waveform like that. So we get into the realms of having to send a variable signal over to this motor driver, and the motor driver just, delivers this high voltage to the motor, which controls the speed. You probably want some kind of loop back, so we know what's going on. In addition, we've got all the kind of, well, not to there, but in addition, there's some kind of ancillaries, which is stuff like lights, certainly on the Sinclair, horns. You want to have a display, etc. So all of this sits there. So it's kind of where you start, really. In detail, when you start looking at all of these, it becomes incredibly complicated. I mean, the Sinclair system is recumbent. Back wheel there, front wheel there. So aerodynamically, it's quite efficient, but I'm kind of limited by the law on what I can do. I've got this 250 watt power limits to the motor. Aerodynamically, I think actually Sinclair's kind of a really good compromise between what's efficient versus what is comfortable. But as soon as you start looking at e-bikes and formulas, you get into drag. You've got top speed of 15 miles an hour. This gear ratio becomes important. How much power you drive to the motor becomes important. Everything is just really complicated to get right. I think it's quite easy just to slap a load of components together and hope for the best, but I don't want to do that. What I want to do is come up with something which is a really good balance. So where to start, really? Batteries on the original Sinclair were just 12 volt car batteries, effectively. I think they weighed something like 15 kilos. They were a bit ridiculous. Within the last 25 odd years, you got lithium ion, which is quite common, whatever that is, Li. And certainly looking at a lot of e-bike guys, there's this 18650 cell. 18650 cell seems to be just a very small 3.7 volt battery. There's limitations. You can't pull too much current, else they catch fire. You can't let them get too hot, else they catch on fire. You have to be delicate in how you charge them, else they catch fire. But they're really dense in terms of energy, so you get better range. They're lighter than the lead acid cells, they're reasonably inexpensive if you respect certain things. And if you respect what these Li-on 18650 cells will do, nothing wrong with them. And you kind of pick them up cheap. I mean, I've been looking at, they're 50 cents a cell. The nice thing is they come in isolation. I've seen people gaffer tape banks of these cells together to get up to these kind of 48 volt range. I don't see any problem starting off getting batteries, because if I'm limited to 24 volts because of my batteries, it doesn't matter if I find a ridiculously a 48 volt motor. The batteries aren't going to have enough power in them to drive the motor. Similarly, this motor driver is a function of what the motor is capable of, what the batteries are doing. So I think a good starting point is just to buy a load of these 18650 batteries and play around with them, just see what I can do. You can gang up a load, there's various different things, sort of 10 in series, 5 in parallel, gives you 36 odd volts with, you know, enough charge to get a long distance. I can add more in series, I can get 48 volts. I don't know what the right voltage is for the Sinclair, but these 18650 gives me that, it'll give me that flexibility to do that. Motor driver, God knows. It's interesting. You can pretty much buy all of these on eBay as a kind of self-contained unit. I don't like that. Most of them are hub motors, whereas the Sinclairs, it looks complicated. I've just trying to attach a hub motor to a Sinclair looks complicated. They also have twist. They also all seem to have twist throttles. Well, with the Sinclairs, your arms are down low anyway. It's going to be a question of twisting the wrist too much. So I don't know. And my objective with this project's not to find an e-bike. It's to build a project. So I could just get an all-in-one. Actually, I don't think that'll be fun to build, and actually I think it'll be quite poor in terms of the final result. So I'm going to stay well clear of that kind of pre-packaged solution. Controller side of things, I mean, that's just a microcontroller. It's a microcontroller electronics. I haven't done any electronics since '99. Did quite a bit of pick work in uni, but it's probably so out of date. It's practically none. I mean, so trying to start off looking at this, I can continue with the controller. I can use an LED in lieu of the motor driver while I work on the controller. So the two things, controller and batteries, I can work on first. I can get practical results out of both of those. In the meantime, I can look at the formulae and requirements for the gears, the motors and the motor driver, which will derive from what I can get out of the batteries and what I can do with the controller. Looking at these controllers, inputs, ancillaries, I mean, you need a throttle, you need some sort of PMO, which is, the throttle will be an analog in, pulse width modulated signal, that'll be an output. You need a kind of speed from the wheel, which will be some kind of interrupt input. You kind of need stuff like left indicator, right indicator. Might as well go in here, or their outputs. I suppose you need a controller on the steering column, so you've got an output and input on those two. You've got a headlight, which is an output and an input. You've got a brake. I suppose when you brake, you don't want to run the driver. So you've got the brake light first of all, which is an output and an input. You've got a rear light if you're at night, which is an output. I suppose you've got a headlight, which is again an output. Both of those need an input. Might as well turn them on at the same time. You've got the motor speed as well as the throttle. For cases which is some kind of interrupt. These lithium ions, they're quite sensitive, so you need battery voltage. If they drop too low, you destroy the batteries. You need a temperature on them. Don't know how many packs I have, so let's just call, let's say 6 of each. My guess is probably 2, probably 4 battery packs. You've got an LCD kind of output. I think LCDs are kind of like 6 outputs. You kind of need a road and track. Kind of, I want a road and a track selector, which is an input, something like that. And I've got, on the display, you kind of want mode, which is, let's just say 2 inputs. Horn. I know technically you can just wire the horn straight to the battery, but if I run it through the controller, I can have I can turn it into an alarm, i.e. if the battery voltage drops, show it on the screen, signal an alarm. So that's another input. So blah blah blah. Let's just say. So you kind of. I can't be asked. Let's just say 35 GPIO pins ish. You could kind of minimize these. You make, if I break, blah blah blah. But let's just call all that roughly about 35 and be done with it. So I've got some microcontroller I need to do, but if I've got microcontroller, that's irrelevant, blah blah blah. So 2 areas to look at: microcontroller and batteries. This is mechanical, this switches, but we'll see.